Okay, let's give you guys some more practice. If you punch this into your graphical calculator, you will get this curve. Let's zoom into this bit here. Hang on. Let's zoom in to this bit here. So zooming into that bit will give us this. So integrate. Find the arc length from 0 to pi over 4. So we'll move from 0 to pi over 4. So work out this arc length here. So press pause and have a go. Okay, so to work out the arc length, we would need to square the r. So we've got to put this into the r here, and then to work out the arc length, we would need dr by d theta, meaning we would need to differentiate this. We need dr by d theta, and then later on we can square it and then put it into here. Well, looking at this, we need dr by d theta. So now, so to work out the arc length, we would need to make use of this. So now looking at this, let's square it. So looking at the radius, we can then square it. That will then give us r squared. And looking at the radius, we would need to find dr by d theta. So we would need to differentiate it. If you differentiate this, it will then give you this. Tidy this up, it will then give you this. Now then you would square this. So squaring dr by d theta would then give you this. So now we've got our r squared. Now we've got our dr by d theta squared. We can then put it into here. So looking at this, we've got our r squared. We've got our dr by d theta squared. So putting this into here. And earlier up there we can put it into the r here. That will then give us this thing here. Okay, and then now let me think. Now if you look at this here, factor out this. So factor out this. So looking at this here. Now looking at this, at the moment you've got this block equals this block. Sorry, at the moment you've got this block plus this block times this block times this block here. So now factorize out this block. That will then give you this. Well, that will then give you this. Okay, so factorize out this block here. That will then give you this, because if you get this and multiply this and multiply this, that will then take you back to here. So from here, factorize this out. That will then give you this. Now looking at this, exactly the same angle. So that this thing here will become 1. So here you've got this thing multiplying with the number 1. So this here can really disappear, giving you this. Okay, and then now this is a constant. Take the 8 out. That will then give you this. That will then give you this. And also here you've got if you square root this, it will give you this. Okay, so from here, that will then take us to here. And now make use of this. We've seen this many times, so you've got to know this by now. Just bear in mind that this angle here is twice the size of this angle. Okay, just bear that in mind. This angle here is twice the size of this angle. So making use of this. So this is like theta here. I'm just bearing in mind that this thing here is twice the size of this thing here. Well, if you look at this at the moment, that's our angle at the moment. If you want twice the size, then you times it by 2, but then it gets multiplied to the top. So that will then give you this. Okay, so from here, that will then take us to here, and then take out the constant, the half here. So take it out. That would then become a 4. And now this is straightforward to integrate. So integrate it. It will then give you this. Okay. So if you're trying to integrate this, you're looking for something. You're looking for something in such a way that when you differentiate it, it will give you this. Well, make this to be your initial guess. Make this to be your initial guess. So hang on. So make this to be your initial guess. Sine 2 theta over 3, and then stick a minus in there because you've got this minus here. So when you differentiate this, when you differentiate this, it will then give you this minus 2 over 3 sine cos cos 2 blah blah. We've done this many times, but then you would need to negate this thing. So you would then go back to your original initial guess, make the adjustment here. So try to negate this. So that would then be 3 over 2. Well, integrate this, it will then give you this. We've done this many times. Okay, so hopefully you would know that by now. So now integrate this. That will then give us this here. Now put this into here. Put this into here. That will then give you this. But then you take away and then put this into here, which will be 0. Put this into here. This whole thing here will be 0. Taking away 0, so you can pretty much forget about this bit here. So this thing here will then take you to here, and then it's and then whenever you see this, so pi over 6. Well, from here to here is pi over 6. Well, from here to here is pi over 2. So divide that by 3. So that will then give you pi over 6. Pi over 6 is really like 30 degrees, because you're cutting 90 degrees into 3 equal parts. So pi over 6 is like 90 degrees. Well, pi over 6 is like 30 degrees. Well, if you're, whenever you see this, think of 30 degrees. Well, 30 degrees, think about this famous triangle where you have the adjacent as 1, the hypotenuse as 2, then this is 60 degrees, this is 30 degrees. Well, 30 degrees is pi over 6. Sine, well, the point I'm trying to make is that whenever you see this, think about this famous triangle where you have a length here of 1, the hypotenuse of 2. This here must be 30 degrees, which is pi over 6. Well, if you want sine of that, sine would be this. Sine would be this, so it would be 1 over 2. So sine pi over 6 is 1 over 2. So this thing here is this thing, and then blah blah. That will then take you to here. This is your final answer. Pi. So that arc length is actually pi minus 3. Okay, so this is your final answer.